Welcome to clickmyproject.com. Our product title is a solar power generation system with a 7-level inverter. Let us see about the abstract of our product. The proposed design is a new solar power generation system which is composed of a DC to DC power converter and a new 7-level inverter. The DC to DC power converter integrates a DC to DC boost converter and a transformer to convert the output voltage of the solar cell array into two independent voltage sources with multiple relationships. This new 7-level inverter is configured using a capacitor selection circuit and a full bridge power converter connected in cascade. The capacitor selection circuit converts the two output voltage sources of DC to DC power converter into a 3-level DC voltage, and the full bridge power converter further converts this 3-level DC voltage into a 7-level AC voltage. In this way, the proposed solar power operation system generates a sinusoidal output current that is in phase with the utility voltage and is fed into the utility. The salient features into the proposed 7-level inverter are that only 6 power switches are used and only one power electronic switch is switched at high frequency at any time. A prototype is developed and tested to verify the performance of this proposed solar power generation system. In this proposed implementation is done in MATLAB simulating environment. Next we see about the flow diagram of our process. In this flow diagram, the input source is a solar panel. The solar panel delivers the DC supply, and also in the solar panel is convert the solar energy into the electrical energy with the using of solar irradiance, and the output of the solar panel is fed into DC to DC converter with coupled transformer, and also in the DC to DC converter purpose is boosting the voltage from the solar panel output DC voltage. So that converter block is boosting some value into fed into the DC to AC converter, and both DC to DC boost converter and DC to DC AC converter is triggered from the PWM controller. In the purpose of DC to AC converter is converting the one form of electrical energy into another form of electrical energy, that is converted into DC to AC form of electrical energy, and finally that output of DC to AC converter is fed into the load. In the PWM controller is generate the pulses for how much switches, power electronic switches is connected in DC to AC converter and also DC to DC boost converters. In MATLAB simulating have only solar array, so we must create a PV module using the solar array. In this PV module consists 72 solar arrays. Those are connected in series when the irradiance values is given to the solar terminal. Solar cell converted solar energy to electrical energy. A solar cell or photovoltaic cell is a device which generates electricity directly from visible light by means of the photovoltaic effect. In order to generate useful power, it is necessary to connect a number of cells together to form a solar panel, also known as a photovoltaic module. There is more about the different type of solar cells here. The nominal output voltage of a solar panel is usually 12 volts and they may be used singly or wired together into an array. The number and size required is determined by the available light, and the amount of generated by solar cells is determined by the amount of light falling on them, which is in turn determined by the weather and time of day. In the majority of cases, some form of energy storage will be necessary. Next we see about the running process of our product. In the proposed implementation is done in MATLAB simulating environment. First open the MATLAB main window and create a new model file. After creating a new model file, we are arranging the elements from the library browser in the MATLAB simulating. From the library browser we mainly used two blocks. One is the sim power system block, another one is the commonly used block. From those blocks we getting the elements and arranging that elements as per the circuit diagram in the given base paper. After that we arranging the elements, we set the values as per base paper, and also some values not given in the base paper, so take as the general reference values, and also the pulse modulation technique controller is used, and also this values is taken as a general reference. After find out that the corresponding output only we did, and this output only we the client requirement, so we did this only, and also the finally the output waveform is getting from the corresponding connected scopes. Then click the run icon. After run that, the scope will be open. In that scope which output we will go to see, that will be shown. And this is the IV curve. This curve is drawn between current and voltage is getting from the solar panel, and the next one is the PV curve. This curve is drawn between the power and voltage is getting from the solar panel, and next one is the power, current and voltage in the solar panel. And this is the solar output voltage waveform. The voltage is around 44 volt, and next one is the current waveform, and next one is the power waveform is getting in the overall panel. Totally in this circuit we using 6 panel of the circuits, and the next one the current waveforms, and this is the output waveform. This waveform is multi-level, around 7 level we can get, and this is the levels. So this is 1 2 3 4 5 6 7, so this is the 7 level inverter. So this level is called as the 7 level inverter. After that, this is the voltage waveform of output, and this is the current waveform of output, and using of level increasing, the overall total harmonic distortion of the current waveform will be reduced, so the overall efficiency will be increased. Thank you for watching this video.